Hello guys, welcome back to another geometry video with Gonzo. Today what we're going to be doing is we're going to be going over the new unit, which is going to be circles. And today I'm going to go over just like a small intro to circles. We're going to go over a few vocabulary words, and there's going to be a little bit of math, but not that much. Right now we're just going to go over the basics of what circles are and all the different types of vocab that are related to circles. So let's get started. So I went ahead and wrote some definitions, and I also drew a little diagram so that y'all could see what I'm talking about when I'm going over these definitions. So the first one we have here are going to be, we're going to go over some lines. So the first one here is tangent. This is a tangent line. And we all have heard of tangent when we're dealing with trigonometry. So we're gonna set that information aside, and we're going to, I guess, learn some new information when it's being related to circles. So a tangent line with circles is going to be a line that passes through a single point of that circle. So a single point, it only passes through one point. And so I don't know if you've heard the phrase, I was talking to someone, but then they went off on a tangent. So that phrase comes from I feel like this diagram, because whenever you, let's say you're talking to someone and then like at a certain point, they just go off in a different direction. They don't like continue on with the conversation. This helped me personally remember what tangent lines are. It's a line that kind of just gradually touches the circle and then just goes off on its own and does its own thing. So that's a tangent line. So a secant line, the next vocab, a secant line is going to be a line that crosses through the circle at 2 points, and it crosses through the circle, which is why I put arrows here. This is very important because there are other lines where they seem to cross through the circle, but they don't have arrows. So if you don't see those arrows, that means that it's not crossing through the circle. It's just touching them. But a secant line always crosses through the circle. So here we have an example. This is secant line BC. And as you can tell here, it crosses through point B and crosses through point C. So these points can be wherever on the circle. As long as this line crosses through two of them, we can name it a secant line. So a tangent line crosses through 1 point. A secant line crosses through 2 points. Cool. So a chord. A chord is going to be very similar to a secant line, except what's the difference that we see here? Well, we don't see any arrows, which means that a chord is going to be a segment that connects 2 points of a circle. It connects. It does not cross through. So the important thing here is that a chord is different from a secant line because it merely connects 2 points, as shown in this diagram here. So the chord here is going to be chord DE, and it just connects point D to point E, and that line there is a chord. Cool. Next one. So a center. So I went ahead and put this vocab in because I think it's really important to know that whenever I'm talking about the center, I'm talking about the point dead center of the circle. And typically, when we're talking about circles, or when we name circles by their center. So if I'm talking about this circle right here, I would say circle C is being shown on the paper right now. So I use the center C and I label the entire circle C. So whatever letter you see in the middle, that's going to be how you're labeling your circle from now on. And you'll see that in the future. Diameter. So hopefully everyone has heard of diameter by now. So diameter is going to be a line. It's going to be a chord, I should say. It's going to be a chord that passes through the center. So you'll see circle P here. And you'll see that there's a chord that passes through center P. And since a chord passes through center P, then we can say that this chord right here is a diameter. And thinking back from previous grades, hopefully everyone knows what a diameter is. A diameter basically connects one side of the circle to the opposite side, and it passes through the center. So that's kind of like a rough explanation of what a diameter is. And so don't worry, we'll go into more detail if you're still confused about what this is. All right, next we have a radius. Again, this is a term that I feel like everyone should know by now. Everyone should have heard of what the radius of a circle is. I know people get it confused with the diameter, but the main difference between a radius and a diameter is that, well, a diameter is a chord that crosses through one end of the circle to the opposite end, the full line right here. Whereas the radius only goes from the center to one end of the circle and one point. And so it goes from the center to one point at the edge of the circle. So it's really just, if you think about it, it's going to be half of the entire diameter. It's only half, which is why there's an equation out there that says the diameter is always twice the radius, because if you take two radii and you connect them, you'll form the entire diameter. So something that you want to remember here is that radii, I should say, of circles are always the same length no matter where you put them. So if I were to put let's say I were to put a radius right here, just going up, this length would be the same length as this one. If I put another random radius over here, this length would also be the same as this one. It's always the same no matter where you put the radius of that same circle. So that's an important note to remember when moving forward. Okay, so next up. This here. Okay, so our next vocab word is central angle. So central angle, we're going to start talking about the angles now. So a central angle simply is an angle that starts at the center. So this is very important moving forward because we're going to have different types of angles shown in circles in the future lessons. So this angle starts at the center and its sides connect to 2 points of the circle. So you'll see here that we have angle EFG, and that angle is going to be theta. So this is very important when writing out the angles because you have to write out, we can't just say angle F. So I'm going to put a little note here. We cannot say angle F. If you say angle F, that is wrong. All right, that is wrong. We don't want that. So instead, what we want to do is we want to name all 3 points. So this angle instead is angle E, F, and then G. And this is red. All right. So make sure that you put all 3 points of the central angle. And remember, a central angle has to pass through the center in order to be called a central angle. Let's say this edge or this vertex was all the way down here and it went up. It didn't start at the center, so that would not be a central angle. It has to start at the center. Okay, so speaking of angles are correlated to arcs. So it's basically the same circle, EFG, except this time we're not focusing on the angle, we're focusing on the arc, which is why I tried to highlight it with red, the arc of the circle. And just to identify, the arc of the circle is always going to be across from the angle that's being given. So if we were to say that this angle is theta, then the arc would also be theta. So it's very important that we know that whenever we're dealing with central angles, here's a big note. Whenever we're dealing with central angles, the arc measure is always going to be equal, put it here, to the central angle. The central, and I'll put angle. So the arc measure is always going to be equal to the central angle. So whatever this central angle is, that's going to be the measure of the arc given. So that's very important because I know there are questions on your quizzes that they'll give you like a measurement here and they'll ask, what is the measure of the arc of EFG? Excuse me. That takes me to my next point. When we label arcs, this is how we're going to be labeling them. So if I'm saying arc EG, then we're just going to write out those 2 letters, EG, and we're going to connect them with little arc. So that's how I would say arc EG. That way you don't get confused between angle EFG and arc EG. Those are 2 different things. So we have angle EFG and arc EG. But those 2 things are equal to each other. So whatever arc EFG is, that's going to be the measure of arc. I'm sorry, whatever the angle of EFG is, that's going to be the measure of the arc EG. And I went ahead and I gave a little example here. Let me put let's put D, let's put E over here. So we have a central angle of 75. So I'm going to put here the central angle, the angle, and I'm going to say DAE. Let's go over here. DAE is equal to 75 degrees. 75 degrees. Now, the note that I just said was that central angles always have the same measure as the arc of that central angle. So the arc, which we're going to note as DE, arc DE, is also going to be 75 degrees because they are the same measure. So this guy over here, this arc measure, is also going to be 75 degrees. So hopefully that helps moving forward, because whenever you see your quizzes, and if they give you a central angle and they're asking for the arc of that central angle, just remember they're the same measure. All right, so whatever this guy is, that's what it is on the outside as well. And that's only guys with central angles. Any type of other angle that we talk about in the future, that does not work. All right, the only time this works is if we're working with central angles, which are angles that start from the center. So hopefully this is making sense. Okay, next up, semicircles. So semicircles are going to be specific circles that are made from a circle that's being cut in half. So when you think about the word semi means half, or to split into two, or two. So a semicircle is basically a circle cut in half. Now this is important moving forward because one, there are different properties of semicircles, and two, there are different ways you can name semicircles. So let's talk about the properties of semicircles. First off, semicircles are always equal to, well, think about this. If we know that a full circle is equal to 360 degrees, and we're only talking about a semicircle, which is half of that circle, how many degrees do you think it's going to be? Well, we take the full 360 and we divide by 2, which is going to be 180. So semicircles are always 180 degrees. That's something you need to know. They're always 180 degrees. Now, naming a semicircle. Now, before I had said that whenever you want to name an arc, you would just take the two endpoints and you would just create like a little arc on top of the letters. So let's say the two endpoints of the semicircle are AC. So we go to AC and we put the little arc on top. Now, here's the problem with this right here. All right. If I were talking about arc AC, am I talking about this guy AC or am I talking about this guy AC? That's where the confusion begins. Now, the reason why this is frowned upon is because of that situation right now that I just said. You could use AC, but there are two ACs. So how can you distinguish between the two ACs? Well, you'll notice that there are some extra points here that we could use. So when you're dealing with semicircles, it is always good to know that there are other points. So let me do this. So let's talk about the semicircle on the top. If I were to name that semicircle on the top, it would be like this. It would be, we have ABC on top, so it would be A, B, and C. And then you just draw the little arc on top. It's connecting from A to B. It's connecting from A to C with B in the middle. So A to C with B in the middle. So we're talking about the top. Does that make sense? If we're talking about the bottom, then we would say ADC, which means that we're connecting A to C with D in the middle. A to C with D in the middle. So that means we're talking about the bottom. So this guy up here was the top, and this guy was the bottom. Hopefully that made sense. And we typically do that with almost all arcs if there are 3 points among the arc. But like on the one on top, if there are just 2 and you can simply just distinguish that when we say these 2 letters, we know for a fact that it's these 2, then you could also use the 2 letters to connect them. But I would start, I guess, writing them in 3 letters, because as we move forward, the arcs are going to look a little bit more complicated. So having the 3 letters is going to help you distinguish which one you're talking about. So just a little note there. Hopefully that helps. So just to retrack, it's going to be that semicircles are always 180 degrees, and then labeling them is very important. All right, hold your questions, please. Okay, so moving on. So right now, intro to circles is just about identifying terms and labeling, I guess, vocabulary. So we're just going over the vocabulary, and there's a little bit of math, which you'll see right now. Okay, so we have 2 more vocabulary words. We have minor arc and major arc. So minor arc and major arc are pretty simple to distinguish, because when you think about the names minor and major, here, let me draw a line here. When we think about the names minor and major, we know that minor is going to be like a small, little. Major is going to be big, huge. So think about those names when you're dealing with these terms, minor arc. So a minor arc is going to be an arc that is less than 180 degrees. So I'm going to put that here. It's going to be an arc less than 180 degrees. All right. So if we're talking about the minor arc of this circle D, the minor arc would be this guy right here, which is going to be A to B, because this guy visually, and we can see that it is less than 180 degrees, because 110 is less than 180 degrees. So the minor arc here would be AB. So I can put AB is minor arc. Cool. So I took that same exact circle and I duplicated over here so that we could talk about the major arc. So the major arc. So we know that minor arcs are less than 180 degrees. So that means that major arcs have to be, you said it, they have to be greater than 180 degrees. So a major arc is an arc that is greater than 180 degrees. So you'll notice in the first diagram, I put the little angle symbol here to show that we're talking about this angle, 110 degrees. But this time the angle thing is on this side. So how can we find what this angle is from here to here? What is this angle if we know that the minor arc is 110 degrees? Well, like I said previously, the length, the measure of it, angles of the entire circle is 360 degrees. So if we know that this entire degree is going to be 360 degrees, but we know that this minor arc right here is 110, then all we need to do is subtract 110 from 360 to find what the rest of the angle is, which would be your major arc. So all we got to do is take 360 and subtract 110, which will give us 250. So the major arc is going to be 250 degrees. So I'll put that here. We know that this is 250 degrees, and I'm going to label these because I forgot to label them. This is A and this is B and C. Now, how do we write this down? Well, we can't say AB. We can't say AB because we already used AB as the minor arc. So what we're going to do instead is we're going to add that third letter, like I said, so that we can show that we're actually talking about this arc on this bigger arc. So when we write that down, it's going to be arc, which is A, C is in the middle, and then it goes to B. So A to B is going to equal to 250 degrees. And that's how you would write that one. And we got 250 by subtracting 110 from 360. So, any questions? That's minor and major arc. Minor and major arc. Hopefully there are no questions. All right, the last thing that I'm going to go over today, which that was like a little bit of math that I was talking about, guys. That's what we're going to be doing. The next section, I guess, part is going to be the arc addition postulate, which includes the rest of the math for this section, which isn't much, so don't fret. What we are doing here is we are, I guess, showing an example of the arc addition postulate. And what this postulate says is that if we were to take two angles and we get the sum of those two angles, then we would essentially be getting the two arcs of those two angles and getting that sum of the two arcs. And you can use this to figure out what, I guess, arc measures are and what angle measures are that are not given. What do I mean by that? Well, let's do this example right here. So the first thing is that they give us a circle B, then they give us two diameters, CD and AE, and they give us one radius, which is BF, and then they give us a central angle of 50 degrees. Well, actually, they give us two central angles. They give us a 50-degree angle right here, and then they also give us a central angle of EBF, which is 90 degrees. So you know this is 90 degrees over here. Okay, so the question would be, what is the measure of angle DBE? What is the measure of angle DBE? Well, DBE is this angle right here. And what can we do so that we can find the measure of this angle? Well, the good thing is that DBE is actually a part of vertical angles ABC and DBE. So these two guys are vertical angles, which means that if this guy is 50 degrees, this guy is also 50 degrees. So simple enough, right? If we found that they're vertical angles, we could say that the measure of angle DBE is going to be 50 degrees. Cool. So what if we were asked, what is the angle measure? What is the angle measure of DBF? What is the measure of DBF? Well, DBF would be from here, DBF. So they're asking for this angle right here, right? They're asking for this big guy right here. Well, we know that this DBE is 50 degrees, and we said in the beginning that EBF is 90 degrees. So if we were to try to find this entire angle, all we would need to do is add them up, add those two together. So we can take the 50 degrees, we can add it to 90, and that's going to be 140. So all this angle from DBF is going to be 140 degrees. And we did that simply by adding the two angles together. Cool. So the last question that it's asking is, what is the measure of arc CF? This time we're not dealing with angles anymore, but they want to know what the measure of arc CF is. Well, we know that CF is this guy right here. This is arc CF. They want to know what the measure of that arc is, which means that if we can find this angle right here, we basically found the same measure for that arc. So we need to find what this angle is right here. So what can we do to find what this angle is right here? Well, we know that AE is a semicircle, right? And semicircles equal to 180 degrees. And we know that FBE is going to be a right angle, which means that it's equal to 90 degrees. So if we know that this entire angle right here is 180, and we know that half of it is 90, see? So all we're left is this half on the left-hand side. How much should these two angles be added up to? Well, they should add up to 90. Since the right side is 90, the left side should also be 90. But we know that this small section is 50, which means that if we were to subtract 50 from 90, we should get the remaining angle. So if we were to take 90 degrees and we subtract 50, that'll give us 40. So that means that this central angle is 40 degrees, which means that this arc measure is 40 degrees. So that means the arc of CF is going to be 40 degrees. And that's how you would find the arc. All right, so that was just a brief explanation of the first section of circles, which was intro to circles. It's not much, it's mainly vocab and a little bit of math, but hopefully this video helps out. I did some examples there at the end. If you have any questions, just go ahead and email me or send me a reminder. Hopefully this helps, guys. Thanks.